Okay, welcome to JC Connect. In the previous class, we were discussing about one problem, that is uh, to calculate the quantity of uh, cement, sand, and coarse aggregate is required. So, through that, um, we solved that problem, and we also calculate how much quantity of cement in bags is required, and make one correction in the problem, that is actually I said it is the density of the cement. It is not the concrete. Make that correction. It is 1440 kg per meter cube is the density of cement. Okay, for concrete it will be normally 2440 kg per meter cube. Okay, so actually in the previous there also it is the density of the cement what we have calculated. Here also we have used. You can see here it is for the cement only, not for concrete. That correction you have to make it. Okay. So this is the calculations what we did. Initially, whenever the things are given like this, first how much dry concrete is equal to how much wet concrete it is going to come. Then for that, how much for 20 meter cube, how much dry this one is required, that you have to calculate. For that, based on the density of the concrete, density of the cement, you have to calculate it. So the second problem, it is with respect to cement mortar. Previously it was a concrete. Here, calculate the quantity of the materials for the following items, that is cement to mortar ratio 1:4 for total how much he has given 1 meter cube of work. Then second one, cement mortar of 1:6 for 1 meter cube of work. So the amount of work, how much they are doing, 1 meter cube of work. Okay, and here this is very important. What will happen is that you are taking the total, it is 1:4 means it is a total 5. In that one part is the cement and 4 part is your the sand. So 1:4, it is 1:4, nothing but cement to sand. That is. So then what will happen is the cement will go to fill up the voids in sand. So then total volume was 4 instead of 5. That is normally when we were doing the concrete and all those things, we calculated it for divided it by total the ratio, but we have taken what will be the dry ratio to the wet ratio, that with that calculations we did. But here whatever today what he has given is that, so it will become um, volume will become 4 instead of 5. So then whenever this is 1 divided by 4, whenever you are calculating, don't divide it by 5, you calculate it for 4. Okay, so then total volume, this is how much, 1 meter cube of work they are doing it. Then so it will become 0.25 meter cube. So again you use the same relation, that is this is 1444 divided by 50, how we have calculated for this one. So again the density of this calculation, density of cement is equal to kg per meter cube, means 1 meter cube we have 144 kg. Then for 0.25 meter cube x So then x into 1 meter cube, that is equal to 1440 into 0.25. 0.25. So you'll get x equal to some kgs, you'll get it. You'll get in kgs. So then next we have whatever we get it, this will be in kgs, this only this portion, and you have to divide by 50. Why we have to divide by 50? One bag is equal to 50 kg. Assume that is x kg. So for this, assume that you are getting 100 here. Okay, this you substitute for this kg. How many bags? This you take it y. This you take it x bag and y kg. You are getting here. So y kg. This you will get it with the calculations. Then you just cross multiply it. So you'll get 7.2 bags. Here also total quantity of sand is required. This is 4 portion is 4 divided by 4 and 1 meter cube. So for one, here also for the similar conditions, second, that is B, cement mortar of 1:6. This is 1/6. I should not take it as 1/7. Okay, I have to take 1/6 because it is raised to 1. So one portion it is always going. Then 1/6 and 6/6. Then the remaining calculation is similar calculations you have to do it. Okay. Similarly, you can do it for this problem also. Calculate it, very simple. And this is for RCC work. So then we'll move on to the um, the second part of this module, that is testing of this. Already you did it in your laboratory. That is maybe in the concrete lab you already did it. So anyhow, we'll move a little bit fast. Uh, Whichever the things are important, that much we will cover. So the testing of concrete materials. And the in this module, testing is there. Then the second one is properties. Which are the properties of this concrete materials? So the first we will consider, we will start with cement property or the cement material. So you have how exactly the cement can be tested in the laboratory as well as in the field. So that we'll see. So in the field test, how you have to do it without whether at least whether the cement is in good condition or whether it is looking like cement or not. So many times what will happen nowadays is that um, the fly ash and cement, fly ash and cement, they are mixing, uh, and we are not getting what exactly happening. This color is also same almost. The cement color is also same. Okay, when you do the laboratory test only you'll come to know, but initially when it is there in the field, how exactly you have to test it or how you have to analyze that, whether it is cement or whether it is some other material, whether it is mixed. Okay, in a field test, how you have to do it: open a bag and take a good look at the cement. Then it should not contain any visible lumps. So color of the cement should be greenish gray. So it should get cool feeling when tested. Okay, so when you insert any finger or to your hand, you should like it will be a thusted. Okay, when you touch the cement, it should give a smooth and not gritty feeling. When we throw the cement on a bucket full of water, before it sinks, the particles should flow. Okay, this is the things normally you have to do. Uh, this is what the common tests without doing the laboratory test. And when we make a strip paste of cement and cut it with sharp edges and kept on a glass plate under water, there won't be any disturbance of the shape and it should get strength after 24 hours. Okay, your glass, that one you have to do it. Okay, or um, make a paste and cut into sharp edges and keep it on a glass plate under water. There won't be any disturbance of the shapes and it get strength after 24 hours. So then laboratory test, this finesse test is there. So then standard consistency tests. Okay, settling time, strength, soundness, heat of hydration, and chemical composition. Okay, so it is finesse test. It about the particle um, uh, size. So uh, we always talk about what will be the particle size of this cement. Particle size. How the size of the particle is going to affect the overall strength or the property of the cement. The fineness of the cement has an important bearing on the rate of hydration, rate to gain a strength, even to the evolution of heat also. The finer the cement offers greater surface area. This is very important. So finer the material, finer the material, so you have greater surface area. So I'll take 10 gram of, assume that it is having 100 micrometers surface area. So another 10 gram I'll take. Assume that if it is 50 microgram micrometers. So then for this case, the surface area will be high. Or if you take this 10 gram of 50 nm, if it is of size of 50 nanometers, then this surface area will be more. So always we talk about the um, in terms of size, as the particle size is um, go on decreasing. Normally, the surface area will increase. Then how to find out this surface area first? So because you cannot measure, it is always the particle size of the cement. If you take the particle size of cement, it will be in terms of micron up to 100 to 50 micron, or sometimes it will be up to 30 microns also. It will be 30 microns also. So how to measure it? So one specific equipment is there, uh, surface area analyzer. Surface area analyzer. So normally we can call it as a BET method. BET method of analysis of surface area. So BET stands for Bremet, Emmet, and Teller. These are three scientists who developed um, the um, instrument to calculate the surface area of any of the finer material. So normally these people, so the three scientists, they have did a lot of adsorption studies, adsorption of pollutants on the adsorbents. So best adsorbent is maybe you might be having in your houses water treatment unit, which is having the carbon filter. So there in carbon filter, the PAC, that is powdered activated carbon, that they have attached to this filter, and it is going to uh, filter the contaminants which are present in the water. Okay, so if um, this powder activated carbon, it is having the higher surface area, therefore, and definitely, as we know that adsorption is surface phenomena. We have one more term called absorption. It is a bulk phenomenon. So means adsorption means surface area is very important, because most of the pollutants are going to adsorb on the surface of that particle. So higher the surface area, more the pollutants are absorbed. But absorption, it is entering to it is, for example, sponge. If you take the sponge means the water is going to enter into the sponge, but not to the surface. If you take the glass, normally glass, if you give a drop of water to the glass, on the glass it is going to flow. That is adsorption. Absorption means if you take a sponge and if you add the water, so inside it is going to enter. So that is absorption. So inside it is going to enter. Okay. Always this, whatever the surface area is very important um, in case of the uh, cement. And one more thing, um, so maximum number of particles in the sample of the cement is less than 100 microns. The smallest particle should have the size if 1.5 microns. Okay, so then it is a variation is from 1.5 micron to 100 microns. Okay, sometimes the surface area as well as the fineness, uh, it is going to play an important role in deciding the strength of the concrete. Okay, always we talk about the gradations, how we talk about in aggregates. Here also, um, 10 microns, 10 microns, how much percentage is there? So 20 microns, how much percentage is there? But in the laboratory, you have to go with the high-end equipment only if you want to find out how much percentage of this much particles are there, how much percentage of this much particles are there. Okay, these gradations are very much important in finding the strength of the concrete. So we have a very good graph. Okay, so this is about the um, I'll show you that graph. That graph is going to show how the size is going to affect the strength of the overall concrete. So this is about the um, size, how exactly it can be calculated. But and one more, the shape also. It is also a very important aspect in this. how the shape of the particles has to be decided. Whether if the particle shape is angular, then how it is going to affect. If the particle shape is circular, how it is going to affect. So then how exactly this shape can be measured? So normally we are going to do it using the SEM analysis. You'll get the features of the shape of that particles, whether it is angular or whether it SEM or TEM. So scanning electron microscope or TEM will go it. Okay, transmission electron microscope. So this is high-end version. Even the particle size of in nanometers can be seen how exactly the shape will be. Okay, even the size also determined. The surface area is, of course, it is determined by the PAT analysis that you have to do it. Okay, even the shape and size can be determined with the help of the SEM as well as the TEM. The surface area it will be measured with the BET method accurately. Accurately, if you want to do it, you have to use that. So then the fineness of the cement is tested in two ways, that is by sieving, by determination of specific surface by air permeability. So here actually the method is air permeability, but what I said, if you want to know exactly the property of the cement, so you have to go with the advanced instruments, that is the SEM, TEM and BET methods. Okay. Normally the surface area is now given by the unit called, so how much meter square of surface area if it is given per kg. Okay, if you take 1 kg of cement, how much SS, that is specific surface area, SSEA normally it is called as specific surface area it is giving. Okay, that we are in meter square. So it is given by meter square per kg. You can see here the specific area, that is per meter square per kg. So if the specific surface area, that is 150, you can see the for 7 days you can see the compressive strength. Again for 150, for 28 days you can see it is 30. For 150 it is 40. For 200 you can see slightly increase in the compressive strength. Here at 28 days you can see increase in the compressive strength. So here also you can see the increase in the compressive strength. So for 250 surface area, again slight increase in the compressive strength. You can draw a circle here and draw the circle here. Okay, for 300, how exactly it will come. 300 here it will be there. So you can see so this is what is your, this is the line. This is the first one, second one. Then what you can conclude from this, as the SSA is go on increasing your compressive strength, that is strength in terms of MPa, it is increasing. Then how the surface area is going to increase. So as the particle size is going to increase, your, see up to some point you can see 300, up to 300 it is increasing. Then so after 1 year almost it is flat, the curve almost it is going to become flat, means this particle size is also having some limitations. Don't be under the impression of that. Okay, if the nanometer, if even the size of the particle is in nanometers, even still if it is going in terms of picometers and all those things, so it has its own disadvantages. Okay, some particular uh, uh, fineness is required for to study or to understand the, because if you see this curve, okay, at some point almost it is going to flat, means even the surface area it is also having some restrictions. So we know that as the surface area is increasing, compressive strength is increasing. How to increase the surface area? So particle size has to be increased, decreased. Particle size has to be decreased. In nanometers means what? It is decreasing. Particle size is decreasing. As micrometer to nanometer, if it is going, so particle size is decreasing. Okay, when it is moving from micrometer to nanometers. Okay, you have to keep it in mind that as the number of particles will increase, of course, our the particle your surface area is also going, but at to some extent. Okay, when it will reaches to some saturation point, at that point, so you have to stop reducing the size of the particles. Okay, so this is about the cement. Then how to sieve the test? Okay, you have to use the IS sieve number 9. So take correctly 100 grams of cement on a standard IS, then break down the uh, uh, air set lumps and sieve it and weight. You already know that, you already conducted it. This weight shall not exceed 10% for ordinary cement, and sieve test is rarely used, and the weight of the residue should not exceed 10% for the ordinary Portland cement. So then standard permeability test. So this is the principle of air permeability method, is in observing the time taken by fixed quantity of air to flow through the compacted cement bed of specified dimensions and porosity. Procedure. So cement required to make a cement bed of porosity 0.475 is calculated, and pass on the air slowly at a constant velocity. So adjust the rate of airflow until the flow meter shows a difference in level of 30 to 50 centimeters. So and repeat these observations for constant H1 by H2 specified for air flow. Okay, and with this one you already know. Okay, so then this is a standard consistency test, and the remaining, anyhow, just go through this uh, apparatus. The remaining things we'll go ahead with the next class. Hmm? Tests on cement.